Now we learn K nearest neighbors, KNN. The KNN classifier is a typical example of a lazy learner. It is called lazy, not because of its apparent simplicity, but because it doesn't learn a discriminative function from the training data, but memorizes the training data set. Analysis of the training data is delayed until a query is made to the system. It can be summarized quite straightforwardly in these 3 steps. Choose the number k and a distance metric. For the new sample, find the k nearest neighbors, assign the class label by majority vote. See this figure. We chose k is 5, and for new data point, and here we found the 5 nearest neighbor points. 3 are from triangles, and 1 is from odds, and 1 is from plus. So the system will predict it is a triangle with this majority vote. So that's the idea. Quite simple idea, and in real applications is quite well working. Here we have pros and cons. Since it is memory based, the classifier immediately adapts as we collect new training data, quite simply. However, the computational complexity in prediction grows linearly with the number of samples in the training data set in the worst case scenario. Furthermore, it's hard to discard training samples since no training step is involved, so that after each point obtained, and we try to use it as part of training set, so storage will increase. So storage space can become challenging if we are working with large data sets. But in reality, it's not happening frequently. Here, more important issue is, along with the right choice of k, the right choice of k is crucial in many cases. And by choosing right k, you can balance the overfitting and underfitting. If you are using the classifier from Scikit-learn, then default k is 5. We may also choose a distance metric from various way. The default is Euclidean distance, and you may choose some other distance from Minkowski distances. P norms, rather than default P is 2, you may choose 1, or the maximum norm, and you can choose various way depending on your data set. The KNN is quite simple, but I personally tested the various algorithms built in Scikit-learn, and also I selected more than 10 data sets, and for each data set I applied 10 classifiers selected from Scikit-learn, And I found that KNN won about 1/3 of data set. That means that for 1/3 of data sets, the KNN predicted the best accuracy. And this is the simplest algorithm, but many cases better than more advanced, more complicated algorithms. So I believe the simpler, the better. So the KNN is not really a cheap algorithm, and it's simple, but it can be very useful in many data sets. Okay, that's the end of the section. Thank you.